All right, this is Miss Cannon. We're going to look at some ways to measure in the science lab. The first measurement we're going to look at is length or distance. You're going to have either a meter stick or a metric ruler. I want to call to your attention that what I'm showing you right here, notice these are inches. We're not going to use that in the science lab. You always want to make sure you go to the centimeter side. When you make a measurement, one of the very most important things to do is notice if here at the end, whether that's 0 or whether you need to come down a little bit to 0. Okay, and your teacher's going to help you with this and everything. But what you would want to do is have the object on the counter, okay, and you're going to want to measure it like that. Not the most difficult measurement in the world. Your teacher will help you with that. Let's look now. I think probably what you need more help on is measuring mass. And so to measure mass, which is the amount of matter in an object, some people want to say it's the weight. And I guess here on Earth, because we're all under the same force of gravity, it can measure weight. But what we want to do is use a piece of equipment called a triple beam balance. And the triple beam balance is has on it a pan. It has different riders that slide down the triple beams. That's why it's called triple beam balance. One of the beams has 100 gram increments, one has 10 gram increments, and one has single gram, 1 gram increments. You're always going to want to use the little knob here underneath the pan. You want to make sure that the pointer is at 0 and you have it all balanced with all your riders on 0. At that point, you're going to place your object onto the pan, and the very first rider you're going to move is the largest one, which on this one is the hundreds. You're going to click it into the next slot. If it drops, move it back one. You're going to go to the next rider, the tens. You're going to click it into the slots. Keep going and going until it drops. Keep going until it drops. Okay, it dropped there. Then you want to move back one. Okay, and then finally you're going to use the single. And you're going to do this until this thing balances and your pointer is at 0. If this were it, we would add up our riders. We have 0 on the 100 grams rider, 40 on the 10 grams, and it would be 41 point, and you have to pay attention here. I believe this would be about 41.3 grams. This object's mass is 41.3 grams. Now, let's flip over from mass to volume. Volume is how much space an object takes up in the world. And the volume of an object can be determined based on, first of all, is it a regular shaped object or an irregular shaped object? This block has a length, a width, and a height that you can see very easily. We would consider this a regular shaped object, and we can easily get the volume of it, how much space it takes up in the world, by using a metric ruler. And we would measure. There's our height, our length, and our width. Okay, and you would get those three numbers and multiply them together, length times width times height. Let's say that this block is 6 centimeters, and this is 3 centimeters and 3 centimeters. So we'd have 6 times 3 times 3. And our unit would be centimeters cubed. That works great for a regular shaped object to determine the volume, how much space it takes up. However, most objects are not nice and neat with an easy length, width, and height. So to determine what we need to do to figure out the amount of space those objects take up, we have to use a method called water displacement. We're going to use a piece of equipment called a graduated cylinder. Okay, a graduated cylinder is the best way to measure liquid volume. Each cylinder has different numbers on it, and for example, this one can hold 100 milliliters of a liquid. This one can hold 25 milliliters of a liquid, and this one can hold only 10. You always want to try to use the smallest graduated cylinder possible for what it is you're trying to measure the volume of. In order to use the graduated cylinder, you're going to need to calculate what each graduation or each line is on the cylinder. And that's pretty easy to do. I always just teach my kids, look at the numbers. I know it's not easy to see, but these go up by tens. It's 10, 20, 30, 40, 50, 60, and so on. So the numbering on here goes up by 10, and then between each number, on this particular graduated cylinder, there are 10 divisions. So 10 divided by 10, each line on here is 1 milliliter. On this graduated cylinder, the numbering system is 5, 10, 15, 20, 25. It's going up by fives. So what I'm going to do then is look, here's 20 and here's 25. How many divisions are there between the two? There are 10. So our numbering system goes up by 5. We're going to divide that by the number of divisions between each number. 5 divided by the 10. Each line or graduation on this cylinder is 0.5 milliliters. Before you use a graduated cylinder, it's very important to figure out what each line means. All right, let's look at this smaller one, the 10 mil one. The numbering system goes up by ones. It's numbered 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What we're going to do is look at how many divisions there are between each number. Here, there are 5 divisions between the 9 and the 10, or between the 7 and the 8, divided into 5 equal parts. So the numbers are going up by 1. The divisions are 5. 1 divided by 5 is 0.2. Do the math. I hope that's right, 20%. So here each graduation or line is 0.2 milliliters. So you have to figure that out. All right, what you're going to do, we have a marble here. A marble is irregularly shaped. We cannot measure length, width, and height. It does not fit in the 10 milliliter cylinder. The 100 milliliter one is just way too huge, okay? We're not going to see a huge difference. So what we want to do is use the smallest one we can of what we have. So we're going to use the 25 milliliter one. I'm going to go put some water in this. Does it matter how much water? Not really. You just need enough to be able to cover the irregularly shaped object. Hang on. All right, I got plenty of water to be able to cover the marble when I put it in there. And what I'm going to do is, first of all, make sure the graduated cylinder is flat on a surface. I'm going to get eye level and I'm going to read it. I'm going to take a reading. And this one I had figured out that each division was 0.5. So it is at about 14 milliliters. I'm going to gently place the marble in. I'm going to let it roll down the side so it doesn't break the glass cylinder. I'm going to look at what it is now, and I'm just doing this quickly, maybe not perfectly accurately, but it looks like it's 15.5 milliliters. If that's the case, then it went up from 14.0 to 15.5. It increased by 1.5 milliliters. Therefore, the volume of the marble is 1.5 milliliters. Interestingly, you could also say if it were a regularly shaped object, its volume is 1.5 centimeters cubed. Of course, 1 milliliter equals the same amount of space as 1 centimeter cubed. Now, there is another piece of equipment called an overflow can. Your teacher will demonstrate that in class. Basically, it's for objects that are too big to go into the graduated cylinder. And there's a way you can do that where you catch the overflow in the graduated cylinder to test and see what the volume of the object is. Hopefully this helps. Again, we've got measurement of length, we've got measurement of mass, we've got measurement of volume. The final one is a measurement of temperature. I just want to remind you that measuring temperature in science, we're going to use degrees Celsius. We're not going to use degrees Fahrenheit. Freezing on the Celsius scale for water, the freezing point of water is 0 degrees Celsius, and the boiling point of water is 100 degrees Celsius. And you just get even with the thermometer and take a look at it and make sure you're using the Celsius side. That's what's most important. Okay, that's it.